Okay, thank you, Arthur, and thank you everyone for joining this webinar. I'll be talking about large format additive manufacturing and from pellets to performance. So I'll start topic a little bit more in general, and I'll be focusing on these three topics of the presentation. I'll be covering what are the current trends in large format additive manufacturing, and then additively manufactured tooling as a rapid and sustainable option. And also, I'll be talking about the recycling of additive manufacturing tools, additive manufacturing tools at AirTech. What are our observations and what are the challenges? And Arthur actually covered that topic very well. Something about AirTech. We're established in 1973, more than 50 years ago. We are known as a polymer extrusion company, mainly active in composite consumables. However, 8 years ago, roughly 9 years ago, we started digging into the large format additive manufacturing, and our key members are in the LFM world since the very beginning, since 2013, 2012. So we are evaluating the options in large format additive manufacturing, developing materials, and also we are working as a service bureau in the US and in Luxembourg. Something about the additive manufacturing really in general. This slide is covering the tooling. So why we see it as a rapid and sustainable option, or why it is a rapid and sustainable option. Well, as Arthur also before mentioned, the printing process typically takes a couple of hours. It's from my experience, 1 to 2 days. We also printed tools that they were being printed for 5 to 6 days. These tools were 12 meters long and 2 meters wide, so we have a huge machine. But this is the overview of the entire process. There are pellets, there is the extruder, and there is the tool. And on the tool, we see the part which was demolded. So we are talking about direct tooling. You don't need to do pretty much anything else with the tool. You print it, somehow post-process it. But that's it. So I'll be covering direct tooling here. A little bit more in detail how the process works. I borrowed this paper or this nice overview from NLR in Netherlands. Basically, everything starts with a CAD file. Then there's a necessity to use a slicer. There are a variety of slicers on the market. The slicer will help to slice the part, to slice the tool, and to somehow create the printing process, to prepare the printing process. And then on the third picture from the right, from the left, there is the actual printing. The actual printing from the entire process takes the shortest time. That's, as I said before, tens of hours, but nothing more. I would say the biggest time consumer is the preparing the CAD file, designing the part, designing the tool, and then slicing. Of course, when you print a tool, that applies on all kind of tools in the market, not only additively manufactured tooling. We recommend annealing these tools. So that's another step, annealing these tools in the oven, and then machining the tools when the stress is already released from the tool after the annealing. Then the step number 6 is, I would say, the tool preparation. It means that in sanding, polishing the tool, applying sealers, microporosity sealers, or release agents. Basically, if we talk about composite tools, we approach it the very, very same way. It's also a number on the picture number 7. We have we do the leak check. It's recommended to do the leak check because with that you can be sure that the tool is vacuum tight. If the desire is to use it as a composite for composite part fabrication. And as a last step, we have a scanning. So we need to make sure the tool is within the geometry, within the geometry that was, I would say, set or designed on the picture number 1 while we were making the CAD file. So we need to make sure the tool is in the same geometry as the CAD file. Just covering the current trends in large format additive manufacturing in terms of tooling. Here are a few pictures that we already published in the past. On the upper picture, that's the general tool we use for testing. Then we have a picture of tool that was delivered to a customer in the UK, done for the aircraft demonstrator. The third tool is a tool for resin fusion. It's not visible that it's printed, but it's underneath the I think it's a peel pie, which is right on the surface of the tool. This was printed out of PETG, and then we have the fourth tool on the right upper corner, and that's a fan called repair tool, which was done for a company repairing Boeing 777 engines, which are the biggest one in the world, if I remember. You can see the tool is pretty big. You can see my colleague there. Tool is roughly, I think, 6 or 5.5 meters long and 2.5 meters high, and also 2.5 meters wide. It was printed in 3 pieces, then assembled together, sealed and bolted together, and now it's performing. Here we have on the lower picture on the left side, we have some print of I think it's a blade for either like for rotorcraft or something. Then another picture, it's a standard aerospace looking or aerospace part looking tool with all the stiffeners. I like this picture because that basically shows what AirTech all does. It's entire tool, the material for the tool, and it's also the material on top of the tool, the composite consumables there. And then we have some other toolings. Here, the last one is the trimming fixture. Now about the trends. So I covered kind of the composite part of the thing because that's our background. So of course, number one must be composites, but then we have some tools for thermoforming, concrete casting, silicone casting, metal bending, stretch forming, sand casting, etc. So really doesn't need to be applied on composites, but I'm showing it in composite work because that's our background, that's what we do. There's the opposite world to the tooling, and that's design and use parts. Here are a few examples. Nothing really to say about the design. It's really depending on the project and on the designer. I always say I'm an engineer. For me, the color is a color. So green is green, and white is white, and pink is pink. But there are other colors and so I'm learning that. However, it really depends on the project, on the customer. However, from the material standpoint, the development of these materials is, I would say, as difficult as the material development for tooling because the requirements are pretty high. I'll be covering the requirements in the next slides. The material requirement for tooling materials. So coming back to tooling, then I'll switch back to design. For tooling, it's of course material needs to be somehow high thermal stable, needs to have a low coefficient of thermal expansion, good mechanical properties, excellent dimensional stability over time. So not only for a few parts. Again, good mechanical properties, good surface machinability. I think Arthur mentioned it as well. Most of the tools are machined, CNC machined, and then polished after the manufacturing process. So the material itself needs to be, let's say, capable of these actions. Strong internal adhesion. We always teach customers to obey or to respect the rule of layer time and layer temperature. And then, of course, the material needs to be somehow chemical resistant when you apply the release agents, sealers, but also when you clean the tool with, for example, isopropyl alcohol or similar. And now, material requirements for the design and end-use parts. Typical requirement is salt, water, and moisture resistance, then UV stability or somehow weathering resistance, depending where the object will be placed. The big thing is the flame retardancy, so FR rated materials, or at least low smoke rated materials or low toxicity rated materials. High impact resistance, again, excellent mechanical properties. Thermal resistant, we have applications that are being printed for Dubai or UAE area. So you can imagine that the temperatures there can go pretty high. Chemical resistance, again, long-term creep, fatigue resistance. I would also add one more, which is yellowing. I know that it's a big topic now in the designer world, where the customers, they want to have a clear material, but they want a clear material which will not turn yellow in 1 or 2 years placed outdoor. What materials are used in general, or what materials are meeting these requirements? I would say these are the most used. There are also other, for example, polyolefin-based materials that are also, being used in additive manufacturing widely. But in the tooling, it's mainly PETG, ABS, polycarbonate, and PEI or PSU. The high temperature materials are typically filled with carbon fibers. The low temperature materials or the medium temperature are filled with glass fibers and carbon fibers. In terms of the design materials or the materials that are used for the end use parts, it's a similar. However, we don't see big demand for the high temps, I would say. It's mainly polycarbonates, a lot PETG, I would say mainly it's a PETG, but we have some niche materials like nylons, recycled nylons, elastomers, and again, polycarbonates, depending on the project. There are really very specific requirements for these kind of applications. Arthur covered that very well. I just want to make sure we get a point: recycled and recyclable. Most of the time I'm traveling and visiting customers, and we talk about materials and how we can recycle them, whether the material is recycled or recyclable, and then on top of that there is the accent thing, right? My accent or the customer accent. So there are the recycled materials and recyclable materials, where the recycled is the one that already somehow worked in the previous life. We have the recycled PETG. Then it means that that kind of PETG already was somehow working somewhere else in certain industry. It might be water bottles or packaging industry or everywhere or anywhere where we can find a PETG. However, the recyclable material is the virgin material, but it can be recycled after the installation, the project is over, after the tool is not needed anymore. Then you can take it and recycle it, how Arthur described it. I'll be also covering that in the future slides. So two different things. I would say most of the materials used in large format additive manufacturing are recyclable. There might be a few exceptions, but most of them are really recyclable, and some of them are already recycled and are working pretty well. Recycling, the observations, what we have or what we've done, because we recycle material internally for our own use at the moment. So this was done, I'm be talking about this particular project done in 2024 for a customer in the US, where we took back the tool from him. We cut it on pieces. Then later on, we used the industrial shredder to have the smaller pieces, the shreds that we would be later on using. However, we used the repelletizer or the compounder. We recompounded them again, and we again manufactured pellets. This was done with polyether imide and polycarbonate, because we believe that when you print high temperature tooling, such as tools, let's say going up to 145 degrees Celsius or 180, 200 degrees C, from the printing perspective, it's beneficial to have a uniform size of the pellets. However, for other applications, it might not be necessary, but this is how we do it, and this is what was working for us. So again, everything was cut on pieces before we send it. Everything from the release agents, from sealers, we removed all the inserts and all kind of resin residues that was there before, and then we use the industrial shredder, and then the pieces we again poured into the compounder, recompound it, and manufacture pellets. As discussed before, there is a certain way of blending these materials. MTC already did that in the past. Very nice project. So I think it's a good job to all MTC people. Just challenges here. I'll be wrapping it up very quickly. It's cross contamination, shortening fibers after each time. Polymer degradation. It's necessary to remove gel coat, sealers, surface coating before, and of course all the inserts, adhesives, fillers, everything that you will not need in the recycling process. Last slide from my end. We get the TCT award in 2024 for this kind of project, where we took the tool from a Brumos racing team that races in Pikes Peak in the US, and we took it back, manufactured a new tool for them, and for next season we made it ready for them, and we made the front splitter tool for them. They won, so I hope it was because of that project. That's it from my end, and if you have more questions, there'll be the slot after, and you can also use my email here for sending questions. Thank you very much. Thank you for your attention.